Welcome back, everybody. So another day, another math problem. Here it is. We got this word problem. Two metal cylinders, each with diameter of 8 centimeters, are bound together by a band or a belt. How long is the band or the belt to the nearest centimeters? So what I've done, I've drawn these two cylinders in yellow. You can see them. They're the same, identical, the same. And the other thing that I should mention is that these two cylinders, they need to be touching. So here it is. These two cylinders are touching each other, not crossing, but touching each other. They're just snug. And we have this belt around the two, and I have shown the other side of it that is going wrapping around the two cylinders in the dotted line that you can see. So it's the top view of the two cylinder, and you got this band or a belt around, and we want to know what is the length of this band in total. Now, we do have couple of important information. Number one is that both of these cylinders are the same, and the other one is that the diameter of both is 8. That means they're equal to each other. And based on a couple of information that we have, we can actually extrapolate and know that the radius or radii for both of the two cylinders, there are 4 centimeters. That means we know that the top piece, that horizontal stretch at the top that touches both circles, and it's actually a tangent to the both of the you can call it circles, but metal cylinders, the top view, uh, that distance is actually 8 centimeters, and so as the bottom, because they are the same. So we know though the length of the piece on top and the piece on the bottom, but we don't know is the other part that wraps around the other half, basically half of the circle on this side and half of the circle from the other side. So now we have to go through and do the math on that. So if you remember, the circumference of the circle is equal to 2 pi r, okay? Or you can just say pi times the diameter, d, capital D for diameter. Well, in this case, we have two half circles or semicircles, because where the belt is tangent to the cylinder creates this half a circle or semicircle on both. So that area right here and this area right there, they both of these two regions are semicircle exactly. So together they're one circle. So what we can do it separately. We can say, well, if the area of this thing is a semicircle of 2 pi r plus another half of 2 pi r, because both of them are semicircle, that would, not area, circumference, I apologize, that's a circumference we're talking about. So 2 pi r is a circumference. So basically what we can have is that basically this will end up being 2 pi r again. All right, so this would be the circumference, and the value of that would be 2 times r, which is 4 times pi, okay, and that would be 8 pi. Okay, very good. Now that we have 8 pi, we need to now add, by the way, this 8 pi is centimeters. We will do the math at the end. We have to include the 16. So the total length is 16 centimeters plus 8 pi centimeters. Total length now is 16 centimeters plus 8 pi centimeters, and is approximately 41.1 centimeters to one decimal place. All right, So this is the question that we have gone through. Make sure that you look at every step here. Make sure that you know that there are two parts of this diagram. So one is the tangent part, the two tangents part of the diagram. You got 8 centimeters on top, 8 centimeters bottom. There's a part of the belt that is touching the circular cylinder. So those two are fixed, 8 plus 8, 16 centimeters, and then you find the circumference of the semicircle on both, which end up being one total circle, and then you put them all together, and it's 41.1 centimeters. All right, I hope you found this useful. Please make comments. If I do make mistakes, that's fantastic if you catch it, because that's a good thing. I do make mistakes, and sometimes I get too excited. Other than that, be well, practice, 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 and see you in the next video. Have a fantastic day. Bye.